Okay, so on this video, I will talk about how we migrated from a mininet to Fabric, our project called VCC Visual Cloud Computing. We go to this Fabric's testbed website. To log in, I'm logging in with my university credentials. Then I joined this project called Flynet. First I registered, and then a person from our lab invited me to this Flynet project. We can control everything through Jupyter notebooks. You sign in into Jupyter notebook, then they give you a virtual machine to work on. At the very beginning, what needs to be done is, so we go to Jupyter examples, start here, and here there is a thing called configure environment, which helps you to create configuration files for entering, accessing machines that you create. So you basically need to enter it and just follow the instructions. So here, I'm just putting my username. Username could be found. I'll show you where it could be found. SSH keys. This is your username. Then you take the project ID. Project ID could be found from here. You go to projects, view, and this is a project ID. Then you tell where the keys are, where you will be storing the keys. And the way to generate keys is the following. Easiest way would be through UI. So you go to this experiments, manage SSH keys, and you create two keys, one sliver and one bastion. So you give a name to it, you describe it, and then you choose key. It could be either sliver, bastion. You download it. So you need to download both private key and public key. And once you download them, you go to, you can save it basically anywhere, but the way I did it, I saved it in Fabric config. This is my bastion key. And here in Jupyter Notebook, you tell the location of your bastion key. And then here you tell the location of private sliver key. Then you just run through everything, and this Jupyter Notebook would create Fabric RC, like configuration file, and basically you use it to access virtual machines from Jupyter Notebook or from your local machine, from your own computer. This is how you enter. This is the first things you need to do. And we have several instances of VCC project. I would just go, okay, before that, I'll show you one more thing, that is this connect.sh. This is what we will be using for the command that we will use to enter to SSH into machines. You tell the location of where you keep configs. So yeah, just leads to this location of SSH config, then location of your private key, sliver key. Okay, so this is setup. Now I will show what we did for about the project. Basic Fabric slice configuration, these libraries are needed. Then here we can see the list of available websites. We have slightly different topology. This is old topology. Okay, this is the code itself. We're giving the name to switches, giving the name to nodes, and here we are defining like sites on which we will be running our machines. One way of doing it is through get random, and another way is just here we're just using max because we need IPv4, and get random sites can return some nodes with IPs that are IPv6, not IPv4. Therefore, we are just telling max. Then we define IPs that we will be using. Their subnets. We will be using networks that connect one interface with another interface. Let's say interface of one node with an interface of switch, then image, and then creating a slice and adding nodes. We define the name. We created just a simple add switch nick function that would just take node name, site, and interface name. It would add the node. The parameters are node name, site. This is what we use, like max, image, cores, RAM, switch disk. And then we once for every switch we need to add NICs, and the way to do is through add component. There are three types of NIC, and we're using just the basic one. That is, as of now, is like 100 megabits per second, and we assign that. We use that interface. We just get create and get interface, and then send the and return the node and interface object, which we'll be using later. The same way we would be add hosts. We have 4 hosts. We are doing pretty much the same thing here. And the reason I created 2 functions is because NICs by switches would be used for some other reasons. The code, of course, could be optimized. And here we are creating networks between switches, nodes, and switches between switches and switches. We're giving the name and all the interfaces that need to be connected with each other. Okay. Then this is just a simple function that we create just to check whether or not internet is working on the nodes. And the way to we did it is through just downloading from Git cloning repository of this very project of this Jupyter exercises. Then we just print out the name and the names, and we are just checking whether or not Git clone was successful. On this block, we are just printing out all the necessary information, and here you can see SSH command. This is how we can use this command and just enter to access machines. Here you can also see the MAC addresses, basically like detailed information about every node. We need further configuration of nodes and switches. For nodes, we would download our P4 VCC project. We would git clone it, and then also we would be adding IPs to every node over here. Then below, we're just making sure that all the IPs got assigned and they have the right subnets, the right masks. We would do the same, almost the same for switches, but configuration of switches would be a little more complex. On this blog, we are generating rules based on which our switches would work. Here we are just clearing out the table of P4 and then just adding rules telling that whenever the switch gets this packet to this IP, send that packet to port 1 and port 1 Ethernet port 1 and MAC of H1, and so on and so forth. We have those rules for all the switches. We store that into files, and we would use those files to upload commands. Here we are configuring some ARP tables of nodes. Configure switch. We are configuring switches, and this thing basically what we're doing, we're just uploading a container router setup P4 BNV container into the nodes, and then running that in Docker. And now I'll show you the content of that script. We are passing as parameter interface names. Here I'm just getting those. We'll pass them later on. This command would download the image and run the container. Now this command would just basically wait until the state of the container is running, and then this loop would set up interfaces, assign them to Docker. Docker would own those interfaces, and then Docker would use them. And switch, our P4 switch would use them. Here we again downloading that fabric, our code into Docker containers. Then here we are downloading the actual model of P4. We're generating JSON files, and the JSON file would be used. The JSON file would be used in to assign ports, and to make P4 work the way we expect it to work. Here I just did this like if-else statements to configure if there is just 2 interfaces, 3 interfaces, or 4 interfaces. And so basically this configure switch uploads that code and runs that code on Docker. This command takes a lot of time, so you have to give enough time for it to run. Then this would just print out every outputs of previous commands. Then we are configuring switch tables, those files that we saved, stored previously. These rules would be uploaded to switches. So yeah, we are uploading those rules. And here what we basically do, we can upload the files we need and then run the experiment. But the way we do it is slightly different. We can do everything on Jupyter, but I prefer just logging it into a computer and doing everything from there. Let's say we want to connect to node 1, H1. The way to do is to copy this command, or copy any that SSH command with right location of private keys. We paste it. We are now logged in. You can see that we are inside of H1. We can see what is here. We have P4 VCC. We can run tcpdump. We can choose an interface. An interface would be NS7 mostly. This interface. Then we can run Iperf. And all the commands. Okay, Iperf. Then I have the list of commands that we used. I will add them below this video. So that's pretty much it.